was either written down in the sheets would have been entered into the computer into an Excel sheet or a Lotus table, that time Lotus database. Those kinds of things, a human operator still had to interact with the computer. The only advantage that it brought, searching and summarizing became easy. We can search the report and say, well, how many items did I do casting? Say on say 4th of October. 4th of October was almost 2 months ago. If it was a book, you would have to go somewhere, open up the book and see. Computer would show it directly. That was the advantage that the earliest systems brought. They are scattered. When we say scattered, no, every department would adopt it once in a while. Some department would take it first, somebody would take it later. So these are scattered in the sense that wide adoption was not there. They are also called on-premise systems. On-premise is a terminology that we use in the computer world. The computer is sitting in your shop floor or in your factory, and the data entry was manual. So the computer will be where you are. Data entry is manual, but there are computers here and there. They gave some efficiencies, but they were limited by the scale and reach. When we say scale and reach limitation, some people were adopting, some people were not. And if there are 4 departments which are involved in doing some task, only one department adopting the computer did not change anything else because other departments are still in the manual part, and you would not see so much of improvement or efficiency gain. This is the first thing that happened when the computer. Then what happened was internet connectivity came. So some of us know internet from say 2000s or early 2000s, but all of us know that internet today is very common. We don't really, what do you call, if any one of you uses mobile for listening to songs, some time ago you would load songs onto the SD card. In some places, no, people even go to a store to download a song and they will charge you some 5 rupees or 30 rupees to download a song into your mobile. But today, because of the availability of internet, none of us really save songs on our mobile phone. Most of us might simply be streaming it from the internet as and when we want. So the big change that happened was internet connectivity improved. So when internet connectivity improved, it is not just about people talking. We are talking now through internet. All of you are at different places. I am in a different place, but we are interacting via video call. This is one of the advantage. But the bigger advantage was that the devices, when I say devices, I'm referring to computers. Computers could share data over the internet. For example, right, if your company has plants in 3-4 places, all the data from each of the plant in those 3-4 places could be sent via email to a central office and see what other people are doing, how are the production schedules going on in another plant. That was visible because you need not go anywhere. Nobody needed to send either a post or travel personally to give you some document. They can simply send the document to you via email. So devices could share data over the internet. Now, when this data sharing was started, it enabled communication across various locations in an organization. So when I say locations, you can think of it as different cities or towns. You can also think of it as different departments. Each department is in one room or one building. With the internet, no, even this was possible. I can send a report from sales, marketing to operations or whatever could be done. So this enhanced planning and coordination, which I am very sure most of you would be following today, meaning the planning team will make a plan, they'll send it to the production team. There are any updates or tweaks to the plan, you will discuss via an online call or a meeting, and then the plan is refined and then reshared again. In all this, right, the production team can be sitting somewhere else, the planning team can be sitting somewhere else. They need not always be in the same room to talk. Internet connectivity enabled that. So computers in which updated, they could share the reports over the internet and people could suddenly see a lot of things happening at other places and they could improve their planning and coordination. So this was the second thing that happened. Computers came, records became digital. Internet came, records could be shared across places. The third thing is about sensor development. So some of you would know, somebody in the electronics department or electrical department may be very, very familiar, maybe compared to other people. But we also know that sensing technology improved over time. Today, sensors can measure various things, not only temperature and pressure, light or infrared radiation, whatever. So the picture on the left side is a representation of the sensors. You may not be using all of them, but depending upon what your process will involve, you might be using at least 3 or 4 sensors typically. Now the thing that happened is these sensors earlier, a few years ago, the sensor has to be attached to a computer and would stream the data to the computer, and from there you have to download the report and share it with somebody else. That is what was happening some time ago. But now sensors can directly there are a set of sensors operating in a plant. The reading that the sensor is taking is directly saved to the cloud. When we say cloud, I am referring to your own database sitting on the internet. It is a private database, nobody can see. Cloud doesn't mean everybody will see my production plan or production schedule. Typically, any company would take subscription to some cloud provider like AWS or Google or Amazon or Azure, and then you will set up your database on the cloud and link up your sensors to the database. The data from the sensors will be streamed to the database. It will be saved in the database, and that database can be given access to by your going to work on the data can be given access to that. So when I say cloud or internet, it is not streaming to everybody like YouTube video. It is actually streaming to a database which is sitting somewhere, which is storing this data. So today, sensors are IoT sensors or Internet of Things sensors. They can do real-time data collection from various locations. And then because real-time data is being streamed to the internet, we can also get real-time operations for central plant location. Okay, now anybody has any questions, please feel free to ask. Somebody seems to have unmuted.
Sir, no, sir, you can proceed, sir.
So far, participants. Okay, I will move on, but please feel free to stop and ask me questions in case there are any questions. So we go to cloud technology now. Today there is cloud technology where everything has been moved to the internet. Any company today, small companies or reasonably new companies which are starting today, they do not have on-premise computers, they do not have IT admins and all. All they have will be mobiles or tablets or. So today everybody's software, data storage, data analysis, modeling, all of these are happening on the clouds. And these are examples of 3 cloud service providers. There are many more, but Google Cloud, Azure, AWS are some examples. The advantage of cloud is that it can be scaled across sites with minimal cost. When I say scaling across sites, what I mean is you have a plant where you are doing sensor measurements or where people are operating on the digital world, interacting with computers or tablets. I want to extend this device to access the internet. I don't need to set up a computer specifically for these people. As long as there is a device like a tablet or a laptop or a mobile phone that can interact with the internet, that much is enough. So I want to take this technology to a new site, new location. I don't need to set up a computer there or an AC for a computer there. If I provide internet connectivity, any device that can talk to the internet is enabling cloud communication. So today we are also seeing cloud technology where some of the companies or most of the companies are measurements flow into the cloud, based on which analytics and prediction became possible. Just for an example, right? This kind of streaming data to the cloud and monitoring real-time operations is very popular in Amazon or retail world, e-commerce and retail, where somebody will keep seeing things. It is also common in the world of renewable energy. There are companies which run renewable energy sites, wind energy, solar energy sites throughout the country, throughout the world. Some company will have renewable energy generation sites across the world. They have this monitoring room. People sit there and monitor how are the energy production, how are the devices performing in real time. Some turbine is generating power in South Tamil Nadu, or there is a solar power plant running in Singapore. Somebody sitting in Bangalore can see what is the power production, are there any problems? And if there are any problems identified, they can quickly notify the operator to go and correct it. So with the cloud technology, real-time data visualization, real-time analytics, and real-time prediction became popular. So this is where some of the companies are, which are newer companies which are starting recently. They started recently, so their technology is yet they have not gotten into very significant investment in technology. All those kinds of companies are today moving to cloud native. They don't have anything on the on-premise. They just have devices to go to the internet, and everything else is set up on the internet. This provides them low cost, robustness, no risk of a computer failing and all the data getting lost. All these things are not there today. So this is the context. So with this context, what happened is some companies that interact with humans regularly. When we say humans, advertisements. Earlier, advertisements used to come on newspaper or radio. Today, we have ads in your mobile phone. You open Facebook or you open, say, Instagram or Twitter or any app. No, you will see advertisements. Google also is giving you advertisements today. So advertising is one thing that is interacting with people on a daily basis. Banking is another thing where all of us go to banks, withdraw money, do transactions. And retail stores where people go and buy items. We go to some supermarket or some departmental store and we buy a lot of things. So what happened was, because collecting data, storing it on, these are the industries that first adopted this collection of data and adopted what we call as artificial intelligence. Artificial intelligence is nothing but the science of understanding human behavior. It is not some magic, it is science, like, or you can call it engineering as well, but it is science that to understand human behavior. And companies that interact with humans on a daily basis at a large scale were the first ones to adopt AI, which is why today you see there are AI enabled or machine learning enabled ads in your Instagram feeds or something, or Facebook. If you are on Facebook now, you watch one video, then immediately all other videos that are recommended you watch. For example, right? If you watch a fight clip on Facebook, then from tomorrow onwards, you'll keep getting more and more and more fight clips. That's how it will be. So this is mimicking human behavior by understanding what they are doing and then making a prediction. So that is how artificial intelligence or machine learning became popular, to predict human behavior using the data. This is what AI or ML or machine learning means. Any questions so far on this slide? Anybody from the team? Okay, we have not a moment. So when we say data collection, there are two types of data that is collected. One kind of data is structured data and another kind of data is unstructured data. To put it very simply, structured data are examples of reports, production planning reports that you do in Excel or that you may do in some SQL database. All these are examples of structured data. You enter data into tables. There are rows, columns. You can think of it as a production plan. No? In the production plan, what day, what item will be produced is something that you do. So is stored in tables. Then there is another world of data called unstructured data. This unstructured data is two things: speech or what is spoken, and then video. People do something in the video or people do something in images. You are standing and an image is taken. No? So images and video is one class and speech and text is another class. Both these are forms of unstructured data. They are called unstructured because there is no fixed format. If I ask you, how did you understand things so far? How are things so far in the class? Each one of word only or two words only. Some of you may say long sentence, some of you may say one word, because the response is not limited to the number of words or format and all. No, so it is called unstructured data. So essentially, there are two types of data. You also collect it in the Foundries. You also collect it. The production schedules that you log in, the shift reports that you log in, where attendance is there. What is the completed production today? You enter the completed production into some form or some sheet and then go on. That is also an example of structured data. And then your CCTV footages. There will be CCTV footages from the Foundry, if there are CCTV cameras for safety, or if there are call orders with you, or people call up and then complain about some product or issues with the product. No, those are examples of unstructured data. So these are the two categories of data that most of the companies collect today. Now, with that data, what the other world started doing, you are the world of engineering, but the world of business, what did they start doing? They started collecting this data and started trying to predict human behavior with a hope of doing things that people will like. One example is Swiggy Zomato. If you use it, maybe some of you may use it. If you start ordering some kind of items, then there will be recommendations which are similar items, or for 2-3 weeks, then they will say, we give you 50% off, please come back and buy on our platform. Or Uber or Ola or Rapido, no? When you book taxi or when you book some bike, how does it tell you how much time will it take? What is the estimated cost? That estimated cost comes from machine learning. Another example is of Amazon recommendations, where you go to Amazon or you go to Netflix or whatever. You watch one movie, they will tell you 10 other movies like this. These are all examples of things that have been adopted much earlier, primarily because there is no risk of failure. The only thing that will happen is you will not watch the movie. That's all. There is no damage to anybody if I give you a wrong recommendation. Whereas the world of engineering, whether it is airplane companies or automotive companies or even foundries like yours, there is a risk of damage. If I do something wrong, I may either incur material loss, which may still be tolerable, but in the process, if I hurt anybody or if it causes injuries to anybody, that is a bigger risk for any industry. So typical engineering firms have been machine learning. 10 years ago, when Amazon or Google said we are doing machine learning, people did not jump into. But now regular industries also realize that there is some efficiency gains that we can get by doing machine learning. So they are starting to use it. But one call out is when people say data analytics or data science or machine learning, I would only request you to think that all of it is similar. It is not very, very different. All of them are similar names or similar sounding names. They refer to more or less the same thing. I can call what you are doing as Foundry. I can also call what you are doing as metal. I think both of them are same, but for you there may be nuances. But for an outsider or for most of us, no, they are more or less the same task. Melt the metal, pour it into a mold, and get a casting, get a component or a part. That is what most of us do. So what is data analytics? So data analytics is the following. Data analytics typically refers to looking at the data, processing the data, and then trying to get insights out of the data. So when we say getting insights out of the data, refer to the same thing. I will explain it with one example. Okay. Now let us say there is a section in a particular factory where some things is not going right. There were some problems with production, and then at the end of the day, the manager or somebody will call them and ask, today your schedule was to manufacture or to cast say 45 components. How many did you do? Now, when somebody calls up in the evening and says you are supposed to manufacture 45 components, how many components are done? And the particular person in the factory floor will reply, okay, sir, 20 has been done. Afterwards, there has been a problem in the production. Ask what happened, why did we not, what do you call, what is the problem, how could we solve it and all. The point is, that is one kind of a understanding, that is one kind of arranging the data. But let us say, think of it as there is real-time information available. Let us say there are sensors or there are things that are monitoring production. Then in that case, if there is a production interruption because of some reason or the other reason, for example, right, there is an IoT sensor near the foundry, near the furnace. Every time I pour, it will measure the furnace metal pouring has happened. Let us say there is a sensor which will say whether metal pouring is there. Telling every 1 hour or every 2 hours metal pouring is happening. Somebody monitoring the data will know that, okay, regularly metal is being poured, which means that castings are going on or metal pouring and castings are happening. But let us say the sensor sees that for the last 4 hours, furnace pouring has not happened. Furnace is either switched off or pouring has not happened. Then there can be an alert. It need not really wait for end of the day or end of the week and say what happened. Then somebody supervising it can immediately go and act upon it and say what happened. Suppose there is a component loss, suppose there is something that needs to be replaced, then they can immediately help and supply. To make is data is what happens on the ground. You process the data, it becomes information. You connect the information or connect the dots, it becomes knowledge. When I say knowledge, what is knowledge? In the example that I gave you, the sensor telling furnace pouring did not happen for the last 2 hours is information. Typically, they pour once every 45 minutes. In the last 2 hours, they did not pour, means there is a problem. That is knowledge. And using that knowledge, you go and understand what happens, what is the reason and all. Eventually, you can make business impact. So that is all this image says. All the three. So essentially, analytics means analysis of raw data to draw insights, gain knowledge, and act upon it. Maybe some of the examples that I'm giving may look very primitive to you or very silly, but these are some things that I can think of at a high level. I may not really know exact examples that you are seeing, but some of them are high level examples. Okay, any questions so far? Shiva sir, can you confirm if participants have any questions or anything?
Oh, okay, sir. Okay, sir.
Yeah, team, if there are any questions, please feel free to unmute yourself and ask, or okay, looks like people are fine, then we'll continue. So what is data analytics? Data analytics is essentially drawing insights from raw data, understanding what has happened, and trying to proactively control things so that things do not go wrong. That is basically what data analytics is. And there are 4 parts or 4 aspects to data analytics. Like in maintenance, some of you may be from the maintenance department. Like you have corrective maintenance, preventive maintenance, and then predictive maintenance. Like that only, even in the analytics, what happened. If something happened, data has been recorded about some event. Descriptive analytics will say what has happened. That is what descriptive analytics will do. It can only summarize or analyze what happened in the past. It cannot help you to go into the future, but it will help you draw insights. Then diagnostic analytics is the second step. It will tell you why did it happen. When you practice diagnostic analytics, in a way, no, it is like root cause analysis that some of the engineering people do, maintenance people who are into the world of maintenance, right? If something fails, they will do an RCA at the end of the after repairing the failure to make sure that things do not happen again. So diagnostic analytics is the second part of it. Predictive analytics is the third part. Predictive analytics will be like answering the questions of what will happen. For example, let us say I will give you one simple example of metal pouring in the foundry only. You have a certain system design or capacity in your shop floor. There is a furnace with a specific capacity. There is a certain amount of sand that is used every day. There are so many number of molds that are available, and there are so many people who are operating this shop floor. I want to suddenly make the number of parts that I manufacture. Now I want to increase the number of parts. Okay, very simple. I mean, all of you are very well experienced practitioners, so the example may seem very silly to you. But for a beginner, the simplest thing the beginner will say is, why don't I increase the furnace heat? Let me provide more heat to the furnace so that the melting happens quickly. Instead of melting the metal in
Sir,
1, I will melt
sir,
it in half an hour. Yes, sir, sir, sir. Sure, sir.
sir, I think your screen is not visible, sir.
Okay, I will stop sharing and I'll. Yes, sir. Can you see it now?
No, sir. Sir, for others, can you able to see the screen, sir?
No.
No, sir.
No, sir.
Okay, sir. I'll share it again. Something has happened, might be. Just a moment.
Your connection is also very fragile.
Yes, sir. Sorry, it got disconnected. Can you see me and hear me now? Shankar sir, you are there?
Sir, we can able to hear, sir.
Okay. Sorry, I think the Teams thing stopped, sir. That was the problem. I have joined again. Okay. So can you see my screen again now, Shankar sir?
No, sir.
Not yet.
Sir, please others can confirm, sir.
We couldn't able to see.
No, sir. We are not able to see the screen.
We can able to hear you. Cannot able to see.
Okay. 1 minute, sir. Now?
No.
No?
No, sir. No, sir.
Okay. I will do one thing. Maybe sorry. I'll try to enable screen sharing. Everything is allowed, sir. I have set yes, entire screen, mute website notifications, hello. Okay, you still can't see my.
Hello, sir.
Yes, sir, sir, tell me.
No, sir. We can't able to see, sir.
Okay, I will do one thing. 2 minutes, sir. I will join again. First thing, I will also send the PPT to you. You can share the screen and move. Maybe that is a simple solution. 1 minute.
Okay,
only,
sir.
Only 1 minute.
Okay.
Yeah.
Okay, sir.
sir. Sorry, can you hear me now?
Sir, yes, sir. We can able to hear, sir.
Okay, please go to full screen. Very sorry for giving you homework, sir. Please go to full screen and go to slide number. I think we are on 12. Very sorry, sir. Or if you want, I can try sharing again if you want to. Shivshankar, sir, shall I try sharing one time?
Yeah, yes, sir. Okay, sir. You can try, sir.
I'll try, and please let me know if you can see my screen now. Maybe you should stop sharing for a moment.
Yes, sir. I have stopped, sir.
Okay. Can you see it now?
Yeah, yes, sir. Yes, sir. Okay, sir.
Okay, fine. Okay, sorry for the trouble. Okay, you can see the full screen also. It has gone to full screen. You can see that, right?
Yes, sir. Yes, sir.
Okay, fine. Sorry for the trouble, team participants. Okay, so basically, predictive analytics is about predicting what will happen. So, for example, right, like I was giving you the small example 1 minute before, if a inexperienced person like me in the foundry industry can say, why don't you increase the rate of heating so that metal will melt in half an hour instead of 1 hour and keep pouring quickly? I may simply say that, like we do on the stove now, I want to make the milk boil very quickly, I'll put it on high. That is a very simplistic solution for me. But practitioners like you will know, there is a limitation on the sand, there is a limitation on the manpower, there is a limitation on the pouring ability also. We cannot simply increase the heat and all. So predictive analytics will be doing something like that, where based on the historical data, it will tell you, suppose I want to do something else, what would happen, is what predictive analytics will help us understand. Prescriptive analytics is the last one. It is more about giving prescriptions as to how to run my process efficiently. I want to do something to improve my process. I want to make sure that my operations are more efficient, or I reduce some wastage, some things like that. Prescriptive analytics is what will help you do. That is the last step that people are trying to reach. Almost not many companies are really there at the prescriptive analytics state. Okay, so moving on. So when we go to what does each of it mean, descriptive analytics typically means dashboards presenting data statistics, mean, median, high, low, etc. One example of descriptive analytics is an Excel sheet. So Excel sheet also is descriptive analytics, but the only point is Excel sheet is limited to one computer, one person working on it. If you want to make it available for many people, everybody must be able, you have to share it, copy it to many people, make them open it using Excel, all that kinds of things you will have to do. But Excel, where you have bar charts, line charts, pie charts, all those are a simple example of descriptive analytics. But in the world of data science or machine learning, there are other web-based tools. I don't need to install anything on my computer. I go to a web page and log into the web page. I will be able to see the dashboards. So that way, you do not expect many people to have Excel installed in their computer and be able to access it, but you provide the access to many people in the industry, organization, in your organization. Then, diagnostic analytics is the second part. It typically talks of failures or anomalies or things like that. Reports identifying connections between different sets of numbers is what diagnostic analytics will tell us. Predictive is, like I told you just now, modeling to predict or forecast future numbers. And prescriptive is building an approach to get the desired outcome based on predictions. What should I do to make my things better? Suppose you want to say, within the same factory floor, if I have to optimize things, how can I change the layout, or how can I change my process? What should I do? Should I increase furnace capacity, or should I increase the sand quantity that is available on a daily basis? Prescriptive will be able to answer things like that. Okay. Then moving on. So very sorry. This is a computer thing. I jumped very quickly. Yeah, very sorry. So the first part of it is called business intelligence or descriptive analytics. So business intelligence is what you also hear outside. When people say I work in BI or enterprise BI, this is what they refer to. So in business intelligence or descriptive analytics, what typically happens is the company will collect the raw data. Raw data will typically be saved to the cloud. That data will be stored into a data warehouse. And from there, we do some analysis of the data. And then we go to reporting and dashboarding. And these reports and dashboards are the ones that are seen by the management of the business. For example, again, hypothetically, a company has a production or factory set or production plants at multiple places. No? One plant has constant problem with something. Then the business will be able to identify it after the fact, after every summary report, every monthly report or quarterly report. But if you have a BI kind of a tool, you will be able to monitor in what do you call disruptions on a daily basis. Every day I upload the production report to the cloud. Then somebody will be able to monitor whether the report is going as per plan, or whether the production is going as per plan, or whether something is not working fine. So business intelligence is the first step when everybody or anybody wants to get into analytics. Typically, they start with the business intelligence or business descriptive analytics, so to say. What are the tools? If I have to use business analytics, what are the tools? So these are some of the tools. Power BI is one tool. Power BI is a dashboarding tool. It is, some of it is free. You can use it freely up to some level. And more, later they may ask, if you have used it for more users, they may ask for some money. Tableau is a proprietary tool. Proprietary meaning you will have to pay money to buy and use it. That is Tableau. Power BI is one free tool. And then there are also other tools like Sisense, Zoho, Click, Tipco, Alteryx, and so on. And there are also dashboarding tools in plain Python. When I say plain Python, most of the machine learning people use Python as a coding language. Python is like C, C++, Java. These are the names you might have heard. So in the world of computer programming, Python is also one language. Within Python also, there are dashboarding tools. People can develop dashboards and see. These dashboards can connect to your local database, meaning all my reports I save in a particular location in the computer. The dashboard can access that location. If you provide access, it will access the location and turn the data into visuals like this. Because visuals are easy to understand, quick to understand, and then easy to find out any problems, right? So this is the first step. So typically, when firms or companies want to start their journey with machine learning or data science or AI, typically they start with BI tools. Whatever data that they can collect digitally, let me first visualize the data, because without collecting data digitally, without a process to for the data to flow into the computer automatically, there can be no data science. Data science will assume the data is being collected automatically without effort. If you say that everything that happens, I have to type into the computer, then the amount of data that can come into the computer is limited by your ability. You can only work 8 hours a day or 10 hours a day. You can only do so much entries in a day. Then the every day the data that you may be able to enter will be minimal for data science. And anybody doing data science on that small data may find it useless. It is not working for me, is a conclusion that some people tend to draw prematurely because they do not know or they do not really understand the amount of data required for the model to learn and for it to show some value. So typically for anybody interested in doing things in data science, the first step would be whatever data you are collecting today, either reports or digitally or whatever, try to move that into a dashboard so that more people will see. When more people in the organization see the dashboard, every department or everybody will have something they would want to work upon. And that is how your data science problems will come up. Because I see that something is happening wrong in my shop floor. Is there a way to predict it? That is how the questions would come. That is how data science projects will typically start for most companies. Okay. Any questions so far? Srisankar sir and team. Dalan sir.
Please go ahead. Please go ahead. Sir, people will ask at the end of the session only the
Okay. Okay, sure. Sure, sir. Okay, I'll then go on and I'll stop at the end of the PPT. So what are the benefits of business intelligence now? You have increased productivity and efficiency, better decision making, customer service, greater competitiveness, strategic planning. All these are generic, but there are important, benefits that you see. A proof that all this works is most of the companies today also operate in the business intelligence space. For example, we or many other analytics companies, we work in that space. We do a lot of work for clients who pay us money. So when I say clients pay us money, all that I want you to understand is, if a business which is operating very well in the world is seeing value in something and doing it, it means that there is really value in that. That's the only thing I want you to consider, not somebody coming and telling you some random stuff and going. So that is the proof. When we work on this repeatedly, we see that clients see value, which is why clients come to us to get it done. Not only we, but many other analytics companies are there. Business intelligence companies are there, which do a lot of business in this area. Okay. The second part of it is what is called as diagnostic analytics. So diagnostic analytics, one example in your world is a root cause analysis diagram. Fishbone is one example, right? If something, there is a problem in manufacturing, is it environment problem, machine problem, method problem, man or measure or material? So this is a traditional framework. When you have processes that are clearly defined, engineering processes that are clearly defined, these are the things that you follow, right? When you have good data recording, you will be able to find out what led to a particular problem. Whether the problem, there are some defect in some casting. Is it because of lack of additive in the sand, or is it because of some other problem? Is it because of the casting, the pattern has a problem, or some pulling out, while pulling out the pattern, something happened? No? All that can be understood by doing root cause analysis. So you do it already. Diagnostic analytics is something that most of you or some of you do. You call it root cause analysis. But In the machine learning world, this root cause analysis or diagnostic analysis can be taken to not just engineering processes, but to something else as well. Meaning, there is a small problem in the factory floor, something gets delayed. Diagnostic analytics will be able to identify what would have been the cause for the delay if there are enough sensors. Without sensors, nothing is possible. But diagnostic analytics is not limited to engineering processes where you can identify everything clearly. You can even take it to other processes, is all I'm trying to tell you. So this is something that is common. Diagnostic analytics is something that is common. Predictive analytics is the more important thing that some of you might have seen, some of you might not have seen. But the point is, when you say predictive analytics, we are talking of data science models, machine learning model, AI model, or ML model. When we say model is nothing but a software program that has been trained on particular data set and will react in a particular way. Meaning, if I give it some input data, it will give me an output value. That is what a model is. To simply put, now you can think of model to be not exactly, but to be like an addition, like a calculator. No, there is a calculator. I write an addition function. I send 2 and 3, I get answer 5. I send 5 and 7, I get answer 12. So that calculation is a simple program. That program is predefined and rigid. It will not change. But when you talk of data science models also predict numbers, but they predict numbers based on the historical data. Meaning, given my production schedule and how I have been operating over the last 3 months, the model will be able to tell what would be a typical production that would happen tomorrow. So this is understanding your data and then building models on your data. That is what machine learning models or data science models will do. Okay, so they deal with models for data, and these are mathematical models, and they are used for predictive and prescriptive analytics. So you will come here after you have done some business intelligence tools, shown some visualizations from the collected data, established the process of data visualization, and then you identify that some behaviors in the process are anomalous. Can I predict those behaviors? That is where we will come to modeling. So this part is highly technical for us, meaning highly irrelevant or not very close to you. But generally to call out, these are the names of techniques. Supervised learning, unsupervised learning, reinforcement learning are the names of techniques. So regression classification are techniques to predict values or to predict classes. Unsupervised learning will have clustering and anomaly detection. So this is somewhat technical to data science, but in the Foundry also you can think of examples. So regression can be an example where if I have given previous production schedules or production plans and production, the regression model will be able to reasonably well predict how much will be the production tomorrow. That is one example of a regression model. A classification model, on the other hand, can tell you whether a particular component is defect free or whether a particular component has a defect. By doing an inspection, you send a scope into the object, take images or take photos. That photos you pass to a classification model. It will be able to give you an understanding of the defect in the process, in the component, and say whether this component is defective or not. Today, some of that is manual. People send in a scope and then the expert monitors it manually. If you want to scale and do more inspections, you can take the help of a model. And one other small call out is, in industries which are engineering heavy, like Foundry or automotive or aerospace, machine learning is not expected to replace people, but augment people. Instead of you having to very carefully look at the image, it will give you an initial prediction based on which you can take a judgment call as to whether I will take it or not. That is what it is. It will only make the process faster for you rather than replacing you. That is a misconception that some people have. Will it replace people? It is not at a place where it can still replace people. So these are some models that we use when we say machine learning, and these are some other models that we use when we say machine learning. A/B testing will be very familiar to you, because suppose that a new additive comes into the market and some company guy will say, we have a new additive that will cause more free flow, less sand burnout, all that it will cause. You use my additive, it is better. Some of you will do A/B testing. One batch you will do old additive that you are already using. Some batch you will do the new additive, and then you will see whether the finish has improved, whether the properties of the component are good, and whether the sand burnout has been less and all. No? All this you will see over time. So A/B testing is one thing that you will very well know. So time series forecasting and recommender systems are other examples of machine learning models. So up to this are basically machine learning models. And then there is another mathematical technique that you may already be aware of, which is called optimization. Optimization, you can call it machine learning, you may not call it machine learning. It is a mathematical technique only. But what optimization will help is to optimize your process. When we say optimize your process, it will help you in production planning and all. I have so much sand available. I have so many people doing work. I have so much furnace capacity and have so much time to operate the plant. Then an optimization model will tell you what is the right number of casts or a mix of castings to do, so that you cut down on downtime, you cut down on wasted time, you cut down on wasted molten metal, you cut down on sand usage, what do you call limitations of sand usage and all. It will come up with a production plan. So optimization is also one of the data science techniques. Based on the data that you have, based on your process capacities, it can suggest you optimal plans. So that is what optimization can do. Okay. Then there is another part of it called deep learning. This is what is more popular today to most of you. Deep learning, you might not have heard the name, but you might have heard the name of ChatGPT, LLMs, large language models, and all, generative AI. That name you would have heard. So deep learning is the branch of machine learning which deals with all that. It will use what are called as neural networks. These neural networks will be able to understand various things in the data and come up with output predictions. Very common examples. So these are two examples of two classes of deep learning models: convolutional neural networks and recurrent neural networks. Again, this is for completeness sake only, not for you to understand the nuances very, very thoroughly, because the time is limited. But I will tell you what each of it will do. So convolutional neural networks that you saw on the previous slide, right? This one, convolutional neural networks that you saw here, are used for images. So when you pass an image to the model, or machine learning or the deep learning model, the image will be able to, the model will be able to tell you whether what is there in the image is cat or dog, or where the cat or dog is, or what is the outline of the cat or dog. Now, what is the use of cat or dog here? It is not cat or dog that we are looking at, but what we are saying is we can use these kinds of deep learning image models to do safety surveillance on the factory floor. I will show you an example of safety surveillance in the factory floor, where we can identify whether people are wearing safety hats or not, whether they're operating in the zone that they're only required to operate, and whether they're not going into the furnace area and all. These are the things that we can do with computer vision. Another example is the recurrent neural network, which is used for natural language processing. So when we say natural language processing, the examples are like this. The examples will be like what people are saying as a comment. Somebody will call you up, or somebody will write a comment on your Facebook page of the Foundry. I bought so many components, some of them are failures. If that comments are so many, right, you need a model to understand. You cannot really read through all the 1,000 or 10,000 comments that may come. So you will need to read through that, understand, and then what is happening. So typically most companies today that interact with humans on a scale, at scale, are a lot of human beings, right? They tend to use machine learning models or natural language processing models to understand things. So NLP will understand sentiment. We'll have chatbots that can answer questions about your product or your things. We'll have things like Alexa. No, you talk to Alexa, it will talk to you back. There are things like that. And Sophie is an experimental robot which could answer people in natural language. So these are all the examples of natural language processing, which is also part of data science, which is also part of deep learning. The examples that I'm giving here may seem to be irrelevant, but I will show you some examples that are applicable to Foundry. Give me some time. Near the end of it, the slides will be more relevant to the Foundry. Okay. The last one is generative AI. Generative AI is the more popular thing that all of us know very, very well, because today it is generating images of, say, somebody from America selling tea in India, somebody from India doing something on Mars or doing something in America. All those kinds of things today are being actually done by generative AI. So generative AI is also a class of machine learning models which can generate data. It can either generate images or it can either generate text. So generative AI or Gen AI or ChatGPT, all those things are what these things can do. The examples that I'm showing here are generated by machine. For example, right, you can go and ask a program to say, give me an image of an astronaut riding a horse. It will generate an image like this. The image is very, very realistic. There is a horse, there is an astronaut riding the horse. Horse is running on the ground. There is dust rising because the horse is running on the ground. And then there is sun on one side, which is reflecting on the astronaut and everybody. But we know that there cannot be horses in space. On the moon and all, horses are not possible. So we know that this image is artificial. Similarly, right, generative AI can also generate text. If I ask twinkle, twinkle, it can come and tell me, twinkle, twinkle, little star, how I wonder what you are. All that it can do. So these examples are basically very what do you call preliminary or very silly examples for serious people, but they demonstrate the capability. I will show you in a moment as to how you can use them in Foundry. Okay. So now, so far I've just covered an overview of what is machine learning or data science. What is the context? How did we come to the world where is data science really important? Is machine learning important? Do we need to adopt? Do we need to do something to be in the industry? All that you have seen some context. So what are some applications in the Foundry? I will try to give you. Some of them may be relevant, some of them may not seem to be relevant to you. You are free to ask, but some of these are case studies that we did for other people. Okay, so the links are there here. I have shared the presentation with Sivasankar sir. He will share it with all of you after the lecture. You can follow the link and go and read. But one of the first thing that we did was anomaly detection or predictive maintenance for a steel company. It is the oldest steel company in India. All of you will know Jamshedpur. They have a factory there. So they have sensor data measuring temperature, pressure. They blow air into the furnace. So they have pumps that pump air. So there are a lot of sensors that they have. The company wanted to move from preventive maintenance to predictive maintenance. I don't want to stop and then do something on a periodical basis. There might be some remaining useful life in the component. So instead of just doing replacement every 3 months, every 6 months, every 10,000 hours, can I go to predictive mode where if the item has more useful life, I will run it. But if the item is about to fail, I don't want it to fail and then I get a surprise after failure. I want a model to tell me whether there is an anomaly. So we developed an anomaly detection model for them. Anomaly detection model is a class of machine learning models. It will use numerical data from sensors that are being collected there. That sensor data has been used. We built anomaly detection models for them, and then they have deployed it in their factory. We have been running a project for them for the last 2-3 years in Jamshedpur. We have a small team there which is doing some work on their analytics process. But essentially, this is to tell you or to let you know that it is not as if data science or machine learning has not been implemented in Foundry. There are other companies which are adopting it or which have adopted it already and are trying to do something. And anomaly detection is one of it. So your Foundry may not really exactly fall into this class. You may say, mine is a batch process. I pour once every half an hour, and in between all the processes are delineated. There is no connection between the first step and the last step. I don't really care. You may say that is fine. But if there are processes where the starting step and ending step are linked to each other, and any small problem in anywhere in the step is going to affect all the chain, then predictive analytics is something, or anomaly detection is something that is useful. So we have done this for oldest steel company sitting in Jamshedpur. They have been using it for some time. This is an example. What did we do? We took sensor data that they have. With the sensor data that they have, we built anomaly detection models. What is anomaly detection model? It will tell you, for example, right? All of you might know, if you drive two-wheelers or cars, if there is a problem in the vehicle, it will start making a different sound, a sound which you might not have heard earlier, and you will be able to pick up. There is something wrong with the machine. It is making a different sound. Something is not right. Let me actually go and get it checked. So that is an anomaly detection that we have. If you take it to machines and do it on the machine automatically, that is an anomaly detection process. It is not based on sound only. It is based on sensor data that you see. So this is one example of data science or machine learning being used already in the world of, say, iron manufacturing process or iron ore to iron conversion, right? There are factories in the world, steel manufacturing companies in the world, which are already using it to some extent. Okay. A second example is safety compliance monitoring. So what is safety compliance monitoring? We did this for an oil and gas company. So what do they want? Their employees work in hazardous environments, and they are required to wear what is called as the PPEs. All of you or some of you may know, people who operate near the furnace, you might know very well. PPE essentially means personal protective equipment like helmets, and then safety vests will be there. There will be safety shoes with toe caps and all. Hard hats, bright clothing, safety shoe, all these are components of this thing. And also employees should not go to unauthorized zones. There are people who should go operate only in their region. For example, nobody should go very close to the furnace. There is an unauthorized zone. In a regular factory, you will put a barricade. Say, don't go below this. You either put a barricade or you tie a rope and say, don't go. So what we did was, in this example, the client wanted us to develop a computer vision module which will do safety compliance monitoring from CCTV camera. There are CCTV cameras on the floor. The CCTV camera will be monitoring the place. And whenever there is a video that is being shown to the CCTV, or whenever CCTV is observing some footage, basically we wanted to call out if people are not wearing the hat, they are taking the hat and holding it in the hand, or they do not have the hat on their head, that kind of a thing, we were able to build a model. This model will automatically detect if somebody is not wearing hat, or if somebody is going into unauthorized zones. It will detect and then alert the safety supervisor. How will it alert the safety supervisor? Safety supervisor need not be sitting in a room. We have also enabled email, or we have also enabled what do you call email, SMS alert or phone call alert. The supervisor will get a phone call or will get an alert via the internet and all, and then they will be able to take corrective action. They will be able to go and immediately monitor or supervise and then set things right in case people are behaving in a way that is not known very well. So this is also something that we did long ago. Somebody is already using it. Today there are many solutions like this available on the internet for not for free on the cloud. Somebody has to pay to host it on the cloud and to do it. But if there are locations or sections in your factory floor where safety is a paramount thing, and then people once in a while do something not very expected, so this can be a solution that is applied. The only flip side to it is safety is something that cannot be quantified easily. For example, right, if you say I do this, but what is the ROI for me? What is the return on investment for me? Safety incidents cannot really be quantified as good or bad, or they brought in so much money. No, it is not easy to do that. So this is something that people do to make sure that their teammates are, their employees are safe. Okay, then the third problem that I wanted to talk about is automated asset maintenance. We did this for a North American railroad company. Railroad company meaning train company. In India, no, train companies are all government companies. Government runs the trains and all. That is a different story. But in America, different companies, private companies run their trains. And whenever somebody has to inspect the track, people typically have to walk along the track and see. So the company had an innovative idea. They said we will fix cameras on an inspection car, and the inspection car will travel along the track at say 20 km per hour or 30 km per hour. The inspection car will travel along the track and collect video footage. Now that video footage, typically before we developed the model, the company was using human observers. Somebody will sit and watch the footage. They will keep watching the footage and then flagging faults. That's what they were doing. But that would lead to misdetection errors, because if humans make an error, they get fatigued and then they said, okay, fine, no, there are no faults, that may lead to a problem. So we developed a computer vision model for them, where the model will look at the footage and find out cracks in the track or missing bolts or broken sleepers and all. No, we had developed a detection model that would do all these things. So more information on the case study is also there in the link. I would request you to, for those of you who are interested, no, I'd request you to please go and take a look there. So the links will point out to what are the case studies that we did, and then the more detailed results will be there. Another example, this example I can tell you with very good confidence that some of the participants from the previous Foundry workshop in IIT Tirupati, some of them asked me about it. I was able to write a code and then share the code with the participants. Now even in here, no, there is a GitHub link. You follow this, you will get the link. What is this? This is the production scheduling code. What is production scheduling? You have a foundry and you have different components that are required. There is an order for large vessel, there is an order for small components, there is an order for say nacelle of a wind turbine, there is an order for some other brake shoes or whatever, no, or brake house. Each item will require certain sand, certain amount of metal, certain amount of labor hours. If I have to schedule my capacity optimally so that I do not have waiting time, then we will use an optimization model to do production scheduling. What will it do? It is a simple code that will take in the constraints on sand availability, metal pouring capacity, mold availability, and cooling time. Based on that, it will give you a schedule. So day 1, you do this. Day 2, you pour these components. Day 3, you pour these components. When it says pour these components, you can validate or verify for yourself that the pouring does not exceed the daily capacity. The sand requirement does not exceed the available capacity. The number of molds for each component are not exceeded. The cooling times are also taken into picture. Cooling times meaning if I have only 2 molds for a very large component and the large component takes 3 days to cool, for example, today you have poured 1 component, tomorrow you pour 1 component. This production schedule will not say day after tomorrow pour 1 more component. It will not say that, because the 2 molds that are available to you are still cooling, or you have not yet broken whatever. The sand is still there, not the mold, but the sand is still there. The sand has to be released by breaking or shaking the mold. That will happen only after 2 days. So some of the sand is locked in that bigger components. It will tell you don't pour it tomorrow because metal requirement or sand requirement will not be met. So production scheduling is something that I know from some of your earlier participants that some of you do it on Excel. You try to iteratively do. Let me do this, check this. Let me do this, check this. You will have an Excel sheet where you keep entering numbers and doing the sum and comparison. But a production scheduling tool will give you multi-period production planning. When I say multi-period, I am referring to multiple weeks, not only this week. If there is a production schedule for 1 month, I can generate plans for week 1, week 2, week 3, week 4. That is what we can do. So this code is available here. Anybody who is interested, you can simply go and download the code. There is also an associated Excel sheet. If you are able to run the code and use the Excel, you will get a production schedule. You can modify it according to your need. For your factory, enter the data in the Excel, do whatever you want to, and then you will get a new schedule, which will actually comply with the requirements. It will not be different. So optimization or production scheduling is something that we can do. How much time will it save? I am only doing it for half an hour a week now. You may say that there are people who may spend more time. If it saves at least like 15-20 minutes for a seasoned person, for a person who is a senior person like you, if it is able to save at least 15 minutes, that's a good saving. And this is, in this example, this is free. You just take the code and use it in online in Google Colab or whatever. You can try to take it. Okay. And one other example is text application. So I told you about generative AI. So there is something called as ChatGPT. ChatGPT is one of a generative AI tool. You can use it for free. Some of the versions of ChatGPT are free. You can simply take it and use it. Now, if you can read the images, right? I'm asking, what is the use of graphite powder in metal sand casting? Metal sand casting is my very generic reference to what you are doing. And it will give you an example. This is what it is. Graphite is used for so and so. Anybody who is joining newly, right? Typically, you take a training session. You will put them into training, 1 week of training, 1 lecture every day, kind of stuff. But the more interested people can actually learn it online. Meaning, some of it is from the internet, but basically there can be answers that come from your specific data also. So maybe just one more example is bentonite, right? Does bentonite burn in sand casting process? It will tell you what happens to bentonite. Does it burn or does it get more transformed or whatever, right? The answers are there. So the point I'm trying to make is there are applications of generative AI even in your industry where you can ask questions and get answers. If that is domain specific, meaning I have some documents which are specific to my foundry. I do say iron casting, I do say aluminum casting, and somebody may even say I do casting of some other metals which are not very low temperature metals, which are very, very difficult to cast. I don't know, high strength steel, maybe, I don't know. I want to do casting of something else. That document is only common to, that document is my proprietary information. Everybody may not know it. Even on the documents, you can answer questions. That is enabled via what is called as RAG and vector databases. I upload my PDFs and I can ask questions out of the PDF. Now, why do I want to ask questions? I know it already, not you, but your teammates, your juniors who are trying to learn things now, they can ask questions out of it and understand things better. So that is a generative AI application. We do this for pharma industries. We do it for banking industries. For banking companies, we have deployed RAG and vector database multiple times because they will have call centers, right? People will call their call center and ask questions. The call center employee must be well versed with what is being asked. So we have provided solutions which will talk to the bank's documents, or which will read the bank's documents, understand, and when any conversation comes in, an employee can ask a question, the answer is returned, which is then answered in the call center call. Okay, so I think this is all I have for today, and thank you very much for listening to me. Thank you very much for being patient also. I am okay and I'm open to answer any questions that you may have. And this presentation, I think Shivshankar will share it with you after the lecture is over. He'll send a mail. Whatever questions you may have, please feel free to ask me. I am new to Foundry. I know some of it. I'm a mechanical engineer, but I may not be able to know everything. So I would also like to be able to do a good job in telling you how ML can help you in your problem. Yeah, please.
Yeah, I have one suggestion. Thank you for a
Yes,
beautiful presentation.
Yes,
my name is Dr. Shaborno Roy. I am the head of research and development in Kejual Castings Limited. I personally more or less know about AI and ML, and we also use ChatGPT very extensively in our operations. The paid version of ChatGPT for various things. I think today the foundry industry in India is in a very traditional and a conventional stage. Now, to modernize the foundry industry through AI, ML, data science, you see, the promoters think that it is a very cost-intensive exercise, and probably the return of investment will not come so easily. So I think what is actually required in these kind of sessions is we go through case studies of foundries which have uh, gone through the automation process through data science, AI, and ML, like the Wapaka Industries in the USA, who have done a lot of extensive use of AI and ML and data science, and go through what has been their stage-wise and phase-wise investments and how the return of investments have been generated. So I, as an engineer or a technical person, can understand what is the use of AI, ML, and data science. Maybe not to the extent as you understand, Mr. Devi, but the primary understanding is there. But to be able to uh, uh, meaningfully and effectively convince my promoters to go through the AI, ML, and data science procedures in mm, the Foundry for an effective return and facing competitiveness, increasing efficiency, productivity, and quality, these kind of case studies would be required.
Sure, understand, sir. Yes, that is a more closer example to your people to understand. Somebody else in the same domain has done it, which means I can also do. That is more closer than me coming and telling you I did it in bank or I did it in oil and gas. Agree, sir. That's
Yeah,
what
this is also because
Hmm.
you don't get easily case studies from within India. So you will
Correct.
have to fall back on the international experience, and we
Hmm.
have to take baby steps towards this. So if the case studies are with numbers of currencies, like what
Hmm.
has been the phase-wise and the year-wise and the stage-wise
Hmm.
investment, and how the investment has been recovered through a period
Hmm.
of time, that will give some amount of confidence to the promoters. And I think we need to do that.
Yeah. Yes, sir. Agree. Thank you, sir. Any other
Sir,
questions
is there,
from anybody?
yeah, any other questions, sir? Mr. Bharat, are you interested in asking any question? No. Hello?
Yes, sir.
Sir, shall we close this session?
Sure, sir. No problem.
Yeah, yeah.
Yeah. Thank you all.
Yeah, 1 minute. I have to say
Thank
thanks.
you.
Yeah.
Yeah.
1 minute. 1 minute. Once again, good afternoon, fellow Foundrymen. It is our pleasure. We invited Dr. Vallabha Deevi for this presentation. He has magnanimously accepted to present on the topic, and we are highly grateful to you, sir. Thank you very much.
Thank you, sir. I'm also learning from you, so thank you very much.
We are sincerely thankful to all the participants and hope that you gained some knowledge out of this topic, and then by his way of delivering the lecture. And also, this is going to be a monthly program. Next month, sorry, on 27th December, Friday, 4th Friday, smart manufacturing topic will be covered by Dr. Anuj K. Diwari from IIT Madras. He is also agreed on that day to deliver a talk, and we will be sending a circular through all the WhatsApp group, and kindly join in the team once again. We welcome you, and we welcome once again all of you for the meeting, virtual meeting. And if any other topic needs to be covered, if you are interested, you can tell on us. We will find the suitable speaker or a trainer, and we will bring them here to talk on the topic. If any idea is there, you can tell us now. Otherwise, we will call the meeting to order. Anything, sir?
Thank you.
Thank you. Thank you, sir. Thank you
Yeah,
very
thank you,
much.
sir.
Thank you very much. Have a nice day.
Thank you,
Thank
sir.
you.
Same to you.
Thank you, one and all. Thank you.